welcome back to Year 11 Chemistry. Today we'll be talking about balancing and combining redox half equations. So we've got the 4 steps listed at the top, and then we're just going to go through an example. So we balance all atoms present in terms of the reactants and the product. We balance for all atoms except oxygen and hydrogen. So we do that because basically we want to balance the equation at the end, but steps 2 and 3 we balance for oxygen and then hydrogen. So we've got 2 chromiums on the left hand side and only 1 chromium on the right, so we need to times the coefficient of the chromium on the right hand side by 2. Once we've done that, we then need to balance for oxygen by adding water. So we add water to the right hand side, and we add 7 because we had 7 oxygens on the left hand side, so we add 7 times 1 lots of oxygen to the right hand side. And you might notice that we balance for oxygen first because we do that by adding water, which upsets any balance we would have had for hydrogen, so it makes sense to then balance for hydrogen next. So we have 0 hydrogens on the left hand side and 14 on the right hand side. So we balance by adding 14 hydrogen ions on the left hand side. Then we need to balance for charge by adding electrons. So a good way to think about this is to make the more positive side more negative. So what side's more positive? Well, obviously it is the left hand side because we've got 14 single charge, positive charge hydrogens, and it's not enough to outweigh the 2 lots of 3 charge on the chromiums. So overall we've got 14 take 2, so we've got 12 plus, and we've got 6 plus on the right hand side. So to balance that out, we need to add 6 electrons to the left hand side. So that is a fully balanced half equation for the reduction of dichromate to chromium. So we're going to go through another example now. So we've got a new reactant and product pairing, sulfur and sulfur dioxide. So pause the video, follow the same steps that we just went through, and try and make the fully balanced half equation for this reaction. Okay, so now we're going to go through the solution. So we see that we need to balance for, well, the sulfurs are already balanced, so we can skip step 1. So we go straight to balancing for step 2. So we need to add 2 waters on the left hand side to balance out the 2 oxygens on the right hand side. That will upset the balance of hydrogen, and we have 4 hydrogens on the left hand side and we have none on the right. So we need to add 4 lots of hydrogen ions to the right hand side. But overall we have a neutral charge on the left, so 0, but we had 4 positive charges on the right, so that's why we add 4 electrons to the right hand side. Then we can do a quick double check that all the atoms are balanced and that the charge overall is the same on both sides. Once we've done that, then we know we've got a fully balanced half equation. So I've got 2 more examples here. Pause the video again, go through the same steps that we went through before, and try and come up with a fully balanced half equations. So have a go now. Okay, so we're going to go through the solutions. So if you did not achieve these 2 results, then pause the video, go back and reattempt following the same steps that we went through before. So now we're up to combining the 2 half equations. So we know that a reducing agent reduces another chemical species but is itself oxidized. And an oxidizing agent oxidizes another chemical species but is itself reduced. So what does that actually mean? It means that in a redox reaction we need both a reducing agent and an oxidizing agent, or there needs to be a compound that is both that is reduced and another compound that is oxidized. So visually it looks like this. So we've got something that is being reduced, so it is itself an oxidizing agent, reacting with something that is being oxidized that is itself a reducing agent, and they go through a redox reaction. So when we're combining 2 half equations, basically we need a half equation that is undergoing reduction with another half equation that is undergoing oxidation to make that full redox process. So basically we're going through the same steps as before, but now we're just doing it to 2 different half equations at the same time. So we're just going to go through and balance for silver. It's going to silver 1 cations. So we just have to balance for charge. All the other steps are already done in this case, so we can just jump straight to balancing for charge because there's no oxygen, no hydrogen, and silver was already balanced. So we go straight to balancing for charge here. The chlorine, all we had to do was balance for the number of chlorine atoms. So we had 2 on the left-hand side, then we have 1 on the right-hand side. So we just had to balance by multiplying a coefficient of chloride by 2, and then balance for charge by adding 2 electrons. So once we've got our 2 half equations, we can identify that one is, silver is losing electrons, and that is an oxidation reaction, but chlorine is gaining 2 electrons, so that is a reduction process. So we've done that little self-check in our minds that we've got both a reduction and an oxidation reaction present. Then we just need to balance the number of electrons in each half reaction. So at the moment, we have 1 electron on the right-hand side for the silver, and 2 electrons on the left-hand side for chlorine. So what we need to do is we times the whole equation of silver by 2, and we achieve a new half equation. Now we've got the same number of electrons on both sides. Then we just combine both equations together to form the full redox reaction. So I've just taken every reactant that I see on my left-hand side, so silver, chlorine, and the 2 electrons, and I'll take my silver, 2 silvers, and my 2 electrons, and my 2 chlorides, and I'll form the right-hand side. Then I just cross out whatever is found on both sides. So I can see that I found 2 electrons on both sides. So basically, I can just cancel those out because 2 electrons are going to 2 electrons. So it's just redundant. I can just cross those out and I get a more simplified chemical equation. So that's how we achieve the full redox equation here. Okay, so we're just going to go through the same process again. So pause the video, go through the same 4 steps for achieving the 2 half equations for these 2 reactant product pairs. So have a go now. Okay, so we're just going to go through the solutions now. So through that process, we should have achieved the 2 half equations shown below. If you didn't achieve those, then go back earlier in the video and follow the same steps that we went through before. So now we're going to go through combining these 2 half equations. So if we've got a fully balanced half equation, or 2 of them, one is a gain of electrons, so this one is a reduction half equation, and the bottom one is a loss of electrons, so that would be our oxidation half equation. Then we just need a balance for the electrons in each half reaction. So we've got 5 electrons in the top one and 2 electrons in the bottom one here. So basically what I can do is just multiply the half equations by the number of electrons in the other half equation. So for the top one, I'll times that by 2 because I have 2 electrons in the bottom equation, and then I can times the bottom one by 5, and that means I balance, basically getting 10 electrons in the end for each half reaction. So once I've done that, then I'm ready to combine my 2 half reactions. Combine them into the same full reaction. So then I can start crossing out chemical species that appear on both sides because it's redundant. So I can see that I had 10 electrons on each side and cross those out. I also see I have hydrogen ions on both sides, so I can cross out 10 on the right hand side and 10 from the left hand side. Overall I have 6 hydrogen ions left, and that's all we can cross out. So then we just simplify again. We remove the electrons. I now have 6 hydrogen ions and everything else that I had left. So that is our full redox half equation. So that's it for today. Thanks for listening. Don't forget to like and subscribe, and next time we'll be continuing on with this redox unit. Thanks again.